what quadratic function, what equation led us to get that solution? When we put it into the quadratic formula, minus b plus and minus square root of b squared, all that good stuff, that's what we came up with. 14 plus the square root of 168 over 2. Now, we're not going to ask you to simplify the radical. Let's leave it as it is. And maybe there's a simplified form of 168 over 2, but we'll leave it as it is. How can we go back? How can we go back and get the equation, the quadratic function that generated that solution? How can we reverse the process? How can we rewind, go back and get what in standard form, ax squared plus bx plus c, what was the a, what was the b, what was the c that led us to get that? That's my question for you. Can anybody answer that question? And we're not going to do this by way of, I can't use it, I can't do that. We're not going to do this by way of guess and check. Let's try 2, let's try 9, let's try 52 for A. That's going to take forever. But what do we know about, for instance, the A? I can tell what the A is right now. Think about that. Doesn't that look like the quadratic formula with numbers in it? So what's the A then? Where would the A? Yes. A is 1. Thank you very much. Thank you very much, Ashton. The A is 1. Now, how does he know that? Yes. The only way he could get a 2 at the bottom was A was 1. Go ahead, Shreyash. The B looks like it should be the 14. Actually, it should be minus 14. Because remember, it's minus B. So it sounds to me like the B is actually minus 14. So here's what we have so far. Good stuff, by the way. What we now know, I should be recording, I'm recording, is that the A should be equal to 1. Is everybody clear on why that is? Yes. Okay. So remember that let me write down the quadratic formula. Quadratic formula is this, that x is equal to, I'll erase it afterwards, minus b plus minus the square root of b squared minus 4ac all over 2a. So that's the formula, right? Wouldn't that suggest that this 2 here then is coming from this? So that means that 2a is equal to 2, which means a is 1. That's what it means right there. Shreyash just said, well, if that's true, that also means that this thing here is probably the 14. But of course, because it's positive 14, it means that this was probably negative 14, which is why it became positive 14. Minus 14 gives us 14. So it means that my B is probably equal to minus 14. So that's a great start right there. That's a great start. But that's not enough. I also need a C. I also need a C, and we don't have the C. So we have the A, we have the B, we don't have the C. Yes? So in other words, the B squared minus 4AC is probably the 168. When you calculate B squared minus 4AC, that's where the 168 came from. That's what you're saying, isn't it? Okay. So it means we have the B already. We said the B was minus 14. So minus 14 squared minus 4 times A, which we said was 1, times C, which we don't know what that is yet, that should be equal to the 168. That's what that means, because B, that's what's under the square root sign. Just match them up. The square root sign gives us 168. So really all we need to do is to say that this thing under here is 168. We know the B, it's the minus 14. We know the A is 1, so minus 4 times A times C, we don't know the C yet, we're going to get the C in a second, is equal to 168. We now have, yes. Well, let's keep working then. Let's keep working it through. Yes, Jeff. We're going to find out right now. We're going to find out right now. So minus 14 is, I'm going to say 196. Folks, double check that. That's straight out of my head here. So you want to double check that. And this is minus 4c. Minus 4 times 1 is minus 4 times c minus 4c is equal to 168. Okay. So we're just solving an equation here now. So minus 4c is equal to 168 minus 196. Okay, I'm going to move this down some. Let me put it over here for now. We'll get back to that one later. Yeah, so this is what we have so far. So minus 4c, 168 minus 196. Let me just think for a second now. That should be 16, minus 16. Okay then. You're right, I'm wrong. Thanks. That's why you don't do everything in your head, okay? Negative 28? Okay, thanks. So what's C then? C is 7. No, you can easily check this, okay? You can easily check this. If C is 7, we have a B of minus 14, we have a A of 1. Does all of that work out to be 168? Check it for yourself. I think it does give you the 168, which is what you want. So what's my equation? Here comes my equation. My equation is that y equals, the A we said was 1, so x squared plus, no, minus 14x plus 7. Right? We said the B was minus 14, so minus 14x plus 7. That would give us that solution right there. Yes? It doesn't, so we'll just go with the standard form. Okay? That would make the most sense. X squared minus 14x plus 7 would give us that solution. Okay? Are we doing okay with this so far? All right? All right. Second question. Here's what I'm going to do. I don't have a lot of space. I'm going to put this second question on the second page. Okay. Same strategy, folks. Same strategy. Tell me what A is, because I know what A is right now. What's A? Yes. 2 this time. What's my B this time? Yes, Vanya. Positive 11. We don't know what C is yet, though. All right, that's the thing we need to know. That's the thing we have to figure out. We know the A is 2 because the bottom is 4. We know the B is positive 11 because of that minus 11 at the top there. But we don't know what the C is yet. But we're going to do the same thing again. Yes? Okay. So we're going to say that my B squared, 11 squared minus 4 times 2 times C is equal to the 145. Yes? Because we don't need to. We know that we're trying to find what's under the square root. That's what we're trying to find. We know that when we take the B squared minus 4AC, it gives us this number under here. That's why we're setting it to 145. Okay? Great question. All right. Amira, so far so good? All right. So let's keep going. 11 squared is 121. Minus 8C is equal to 145. Minus 8C is equal to, let's see if I can get this one right this time, 121. So that would be 24. I'm minusing it, by the way. So 24. So I'm saying that C is equal to minus 3. Am I right? Folks, I make mistakes. So tell me if I'm wrong. You let me know if I'm wrong, okay? So C is minus 3. So here's my equation. Y equals 2x squared plus 11x minus 3. There's my equation that had that solution. The last one is more tricky, and we'll see if we can help you through it. That's a little bit more, a little bit more, a little bit more work. But I'm pushing you. Yeah, yeah. That's part of my job is to not just give you stuff that's a walk in the park. It's to give you stuff that's going to challenge you as well. So the last question is this. So we're done with that one. Let me go back and copy that into a new page. It's this guy right down here. Make it bigger first. So this is C. Start thinking about how we're going to tackle this beast. Not as obvious as the ones before. Let me put my cursor back to charge here. Not as obvious as the ones before. Okay. What do you want to tell us? You want to, sorry? Can I go back? Sure. Sure. All right. So Sana wants us to go back for a second here. We can do that. That's this question here, right? All right. So this was B, by the way. But now we have to get to C. No, this wasn't B. This was, oh, hold on. This was A. Let me go back. This was B. Is it B you wanted to see? All right, sorry, this is B. 2x squared plus 11x minus 3. All right. Well, now we have something that's a little bit more messed up. That's this. So let's think about how this might work. Let me get ideas from you first. One of the things we haven't had before is a number in front of the radical, a mixed radical. We had entire radicals. It made it easy. So whatever another radical sign, we're good to go. But sometimes they look like that. So give me some strategies. I saw a hand go up a few minutes ago. Who was that? Yes, it's a cheer. First thing to do, find a what? The A. What do you think the A is? Yeah, we could go with 1.5. That's one approach. We could agree with that, absolutely. I had a different idea though about that. And we also have to deal with the fact that we don't have the radical the way we like it. Okay. And sorry, that's just the way it is, right? The world isn't going to put itself in front of you and say, here, this is the easy way to do it. It's not. So I'm not disagreeing with Sajir's suggestion. He says the A is 1.5 because he's dividing the 3 by 2. So, and we can keep that. We can keep it that way. But I'm asking for some. Okay, go ahead. I like that idea. Let's change this mixed radical into an entire radical. That's one. We'll come back to what we have to do to get rid of that 3 at the bottom in a second. I don't like this mixed radical. That mixed radical is messing me up right now. Probably messing you up as well. Right? We always had it just square root of something, and we could just say b squared minus 4ac was that thing. But here's what Manahill is saying. She's saying we can rewrite this little box on the side here. This 2 root 6, we can make it into not a mixed radical, but an entire radical. So what do we mean by that? If I square this whole thing, what am I going to get when I square the whole thing? Yes. I'm going to get this, which is 4, not 12, times this, which is 6. When you square a square root, you get the number that's under the square root sign. Remember that. So I'm going to get 4 times 6. So if I square this, I'm going to get 4. I'm going to square this, I'm going to get 6. That's equal to 24. But then because I squared it, I have to now square root it back to come back to where it was. So now I'm going to go back to the square root of 24. And guess what? That square root of 24 is the same thing as 2 root 6. When you were doing radicals earlier on, if I gave you 24, you'd have made it into 2 root 6. Isn't that true? Isn't the square root of 24 2 root 6? Think about that. It is. But putting it in this form Makes it much easier for us to work with. So get rid of, that's what Manahill said, get rid of the mixed radical, make it into an entire radical. So I'm going to write this thing again as the following. So it's the same thing as 3 plus the square root of 24 over 3. Now, earlier, Suchir was saying, Suchir, right? Something, okay, Suchir was saying, okay, so the A would be 1.5 to divide the 3 by 2. But you know what? I don't really want that. I'm going to multiply the top and the bottom of this fraction. A fraction, you can do the same thing on the top and on the bottom, and it's still the same fraction. You know what? All right, let's leave it as that, because multiplying the top is going to give us another 2 in front of the root of 24. So I tell you what, I'm going to stick with what you said, and we'll multiply it by 2 at the end. So we'll stick with what you said. We'll stick with that for now. Excuse me. Or we could have multiplied by, you know what? Here's what I could have done. I could have multiplied by 2 at the very beginning, top and bottom, and then we could have made that into an entire radical. But I'll leave it as it is. Leave it as it is. So I'm going to go ahead now. I'll go along with Suchir, right? A better strategy, I think, would have been to multiply the top and the bottom by 2 at the very beginning and then made it to an entire radical. Okay, but I'm going to go along with that. Yes. Okay, could you sign out for me, please, on your way out? All right. So I'm going to go along with that. So my A is equal to 1.5. Does everybody see why that A is 1.5? Does that make sense? A of 1.5 makes sense? No? Okay, Jahim says no. Remember the quadratic function? I'll write it in a box over here. Minus b plus minus square root of b squared. That's ugly. B squared minus 4ac. Remember this? All over 2a. Remember that? So that means that since this is the denominator here, that means that 2a must be equal to the 3. Divide through by 2. You get 1.5. Make sense? All right, I'm going to erase this. So A is 1.5. I can live with 1.5. Don't play with that phone right now. All right? Okay. Oh, it's just, I thought it was the phone you were there playing around with. All right. So, how about my B? Help me out with the B now. What's the B? Yes, Shreyash. What's that? Negative 3. B is equal to minus 3. So what that means is that my B squared minus 4AC is equal to that 24. What's my B? Minus 3. So minus 3 squared minus 4 times A, which is 1.5, times C is equal to 24. Masumi, make sense? Are we good? All right, help me out then, please. What's the minus 3 squared? So that's 9. And minus 4 times positive 1.5 should give us what? You can do it on your calculator. That's okay. So minus 6c is equal to 24. I'm going to go ahead and minus this 9 from the two sides. So minus 6c is equal to 24 minus 9. So minus 6c is equal to, that looks like, was that 15? So that's the thing. It's going to give us a decimal, but that's the nature of things. That if I multiply through by 2, it would have given us a nice whole number, but that's okay. So that means that c is equal to 15 over minus 6, or minus 15 over 6, same thing. Divide the top and the bottom by 3, that's minus 5 over 2. Okay? So we're ready for the equation now. The equation is y equals, instead of saying 1.5, so here I'm going to say 3 over 2. That's the same thing, right? 3 over 2 x squared. Sorry, what was it again for b? I forget what b was. B was minus 3. Minus 3x minus 5 over 2. No, that's okay, but I don't like it. What do you think? What do you think I would do to clean that mess up? Yes, multiply everything by 2. Yeah, that's what I would do. Because it would be the same solution. For everything multiplied by 2 gives us 3x squared minus 6x minus 5. 3x squared minus 6x minus 5. No, I probably should not show this to you, but it don't matter because I'm going to give it to you. I'm going to give you my calculators on the test anyway. Those of you, I know that you have one, for instance. Wanya has no. Wanya has a calculator like mine, my virtual calculator anyway. On that calculator, there's a quadratic solver on there. So if I go to mode and equation, then I go to 3, which is the quadratic equation. I can put in my A, my B, and my C. So in this case, my A was 3. My B is minus 6. And my C is minus 5. There's my answer, 3 plus 2 root 6 over 3. It's plus and minus. I mean, that's the plus 1. You hit it equals again, it gives you the minus 1. So it's exactly what we started off with. Exactly what we started off with. So we know that this solution for this equation is this thing here. But we started off here. We had to take from here and go backwards to find the equation. The calculator is backing us up, though. Did you know that was on your calculator? It might be on yours as well. Can I borrow this a second? Mode. No, yours doesn't have it. Sorry. Yours doesn't have it. Neither does yours, which is good because that's the calculator that you're going to be using anyway. But some of you have calculators that have that feature on it. I believe yours does. Let me see. No, it doesn't. It doesn't, which is good. Which is good. But you saw the keystrokes I went through? Yours might have it. No, you don't have it on yours. No. Okay. All right. Yes. How do you go back to the Greek? Depends on yours. I think you go into mode. That's not it. Okay, so there's a DRG on here somewhere. DRG. Look for a DRG key. And here it is. Every time you press it, it goes from one to the other. It keeps cycling through. So it's on degrees now. Okay. Every calculator is different. Okay. So even from the, yes, let me go in the back. Hashim. Let's see. It's 15 minutes into the class, so unfortunately, we're going to have to hold off for today, okay? All right. So that's those 3 questions. Well, we have more, right? We're going to try to get through as many of these as we can today. We'll do some more tomorrow, give you some time to review, test on Wednesday. All right? Okay, let me close this up. And let's go to, oh, did that already? Okay. I'll make this bigger. Before you even ask, I'm going to make it bigger. Express in simplest radical form the volume of the rectangular prism below. This again was from the problem set, from the assignment. So how does one get a volume? How does one, can everybody see those dimensions right? I can make that bigger if you need me to. Probably should. I give you the length, width, and height of this rectangular prism. 200, that's big, that's huge. You should be able to see that now. How does one get volume again of a rectangular prism? Thanks. Come on, folks, where's everybody else? Do I have to start calling names? Okay, we can do that. We got all the names up here. We can call names. We can do that. We can definitely do that. Don't get nervous. I mean, I have to call on you sometimes if you don't say much, right? Shaluja, can you help me out? How does one get the volume of a rectangular prism? Can you remember how that works again? I want to get the volume and I have the length, width, and height. What do I do? Just multiply all 3 together. There you go. This times that times that. She's right. Now you're thinking, whoa, that's a lot of multiplication. Turns out there's a shortcut for this one. I want to see if I can get you through that shortcut. All right? Sandy, you with us? Okay. Let's first of all simplify what can be simplified. Can any of these things be simplified? Can any of these radicals be simplified? What say you to that area? Can you simplify any of these? Can this be simplified that way? Any one of these can be simplified? What do you say? Any of them. Can any of these radicals be simplified? No? Okay, let me hear from Naomi. Root 54, I agree. Let's simplify that. Hopefully not, well, I know you're not. You're not using a calculator to do it because you need to be able to do it without the calculator. What is the square root of 54 in its simplest form? Go ahead, you can tell us. Anybody? Square root of 54 in its simplest form. Yes. 3 root 6. That's good. Plus, how about the square root of 56? Can that be simplified at all? Go on, folks. Try to put your thinking caps on here. I know this was the quiz you had on Friday. Yes. 2 root 14. Good. Does everybody agree with what we just? Yes. Okay. Root of 56. Look for a perfect square, which is a factor of 56. Think of the perfect squares. Forget 1. 1 is always a factor. The next perfect square after 1 is 4. Right. So we take 4, and 4 is 4 times 4. 56 is 4 times 14, and then you go from, okay. So 2 root 14. So I'm thinking, okay. Oh, sorry, I'm saying this wrong. It's 2, no, hold on. Let me fix this. I'm doing this wrong. It's 2 times that plus this. So this 2 root 54 is 2 times this plus the root of 56. I said that wrong a few minutes ago. So I'm going to say this, that this is the same thing as 6 root 6 plus 2 root 14. And in fact, I could, you know what? Let me change that up. I'm gonna fact. I'm saying too many things at once. Sorry. That's what confuses people. I'm going to, so I took the 2 and the 3 and multiplied them together to get the 6. So it's 6 root 6 plus 2 root 14. Now, is there a common factor between both of these, between the 6 root 6 and the 2 root 14? Any common factor between those two? Because I want to factor that out. Yes, 2. So 2 bracket 3 root 6 plus root 14. Can we agree on that? Okay, everybody agree on that? Okay, just factoring that out. Okay. Now I'm looking around and thinking, that looks a lot like this one right here. Look at that. 3 root 6 minus root 14. It's interesting. So I know I'm going to have to multiply all of these things together. I have to multiply this thing that we just factored out times the 3 root 6 minus root 14. And when I take the result of that, I'm going to have to multiply that by this one right here. So we've taken this and we're multiplying it by these two. That's the only two we're multiplying right now. Eventually, we have to multiply by the third one as well. But let's just multiply these two together. Now look at this. 2 times 3 root 6 plus root 14. 3 root 6 minus root 14, sorry. When you see this, what starts to click in your head right now? What are you thinking to yourself when you see that? Yes. That's that a plus b, a minus b right there. That's exactly what that is. They're both the same two terms. The 3 root 6 and the root 14. The 3 root 6 and the root 14, but one is a plus and one is a minus. So if we were to multiply these two, the 2 is still on the outside, we're going to get something squared minus something else. We're going to get this first term squared minus that term squared is what we're going to get. What is this first term squared? Let's square 3 root 6. What is that? When you square that, yes. 9 times 6. Whoa, what just happened? And when I square the root of 14, what do I get? No, let me get, so thanks. When I square the root of 14, what do I get, folks? What do I get? Yes, 14. So it means that for this, I'm going to get 9 times 6, which is 54, minus 14. So this is going to be, I think that's 40, right? And all of that now needs to be multiplied by the last part of this, which is the 4 root 2 minus 2 root 3. We haven't done that part yet at all. So all I need to do now is just simply simplify this to give me 80 4 root 2 minus 2 root 3, right? And I could factor out 2 out of this bracket as well. 2 into 2 root 2 minus root 3. I'm just factoring out 2 out of the inside bracket. So at the end of the day, I'm going to have this. 160 into 2 root 2, into 2 root 2 minus root 3. I'm going fairly quickly on this one, I know. What's that? I factored out these terms inside here have a common factor of 2. So I just factored out the 2. Okay? And I don't have to go any further. I can leave it like that. That's perfectly acceptable. The 3 things multiplied give me that answer at the end.